All right. Good afternoon and welcome to this week's Iowa Learning Farms Conservation webinar. I'm Matt Helmers at Iowa State University and director of the Iowa Nutrient Research Center. And I'm excited to be back moderating today. Missed it last week, but back today. I didn't want to miss this. Today we have Andrew Hillman with us. Andrew is a PhD candidate at the Nelson Institute for Environmental Studies at the University of Wisconsin-Madison. But also, I hope at least proud alumnus of ISU in the ABE program, and was an Iowa Learning Farms intern one summer, just one summer, right, Andrew? Or
2 summers.
two. Oh my gosh. Okay, two. So I won't say he's the first intern to be on here giving a webinar because Liz Ripley. Oh my gosh, she was Liz Jukums when she was an intern. Now Liz Ripley was one of our first interns and has done webinars. But really excited to see how Andrew's career has evolved and excited that he's back with us today talking about his research, which is investigating disproportionality of nutrient losses in agriculture, the role of perceived vulnerability in conservation and nutrient management. As always, if folks have questions, please type those in the chat box and we'll get those to Andrew at the end of his talk. But with that, Andrew, the virtual floor is all yours.
Thank you. Thanks for the introduction. Yeah, I'm very happy to be here. As Dr. Helmer said, I'm a former intern with the Iowa Learning Farms program, and I can't say enough great things about that program. I really take those summers interning as give them a lot of credit for where my career is today, and so can't thank them enough for that. I'm a Badger these days, but I did make sure to wear my Iowa State hat for this webinar. So, yeah, proud alumni of Iowa State. So, yeah, today we're going to talk about my research, investigating disproportionality of nutrient losses, the role of perceived vulnerability in conservation and nutrient management. First of all, I'd like to thank my co-authors and my committee for their help with this work. Doctors Amber Mays, Margaret Kalsick, Anita Thompson, Ken Jensko, and Joe Bunnell. Yeah, so this study involves a mailed farmer survey in Southwest Wisconsin and Northwest Illinois. So the main title of this refers to disproportionality. So I wanted to spend a little bit talking about what I mean by that in terms of nutrient loading. So you can kind of conceive of nutrient loading as a function of two distributions on the landscape. You have a distribution of farm management throughout a watershed. So you have some types of farm management that can really mitigate nutrient losses, and some types of farm management that might not do a good job of mitigating these losses or even exacerbate losses. Now, also in that watershed, you have a different distribution of the inherent physical vulnerability of the land to nutrient loss. So these are things that are not impacted by farm management or human behavior or land use decisions. These are things like slope, erodibility, proximity to water bodies. So where you have maybe these farm management behaviors that are not great at mitigating nutrient loss, intersecting with these landscapes that are really high vulnerability, that's where you get these disproportionate major nutrient loading impacts. So in general, disproportionality, when I say that, I mean, a field having an outsized impact on the total load of nitrogen or phosphorus based on its size. So again, when I talk about farm management, what do I mean? I think we can conceive of farm management in sort of two bins in terms of nutrient loss and water quality. We can talk about source management. So these are things like reducing N&P inputs, nutrient management planning, as well as sort of your traditional BMPs or conservation practices that are more focused on capturing that phosphorus or nitrogen or mitigating that loss. And then again, physical vulnerability. These are things inherent in the landscape that we can't really change that can also impact nutrient loading from farm fields. So the question we want to ask for this part of my dissertation is, how do farmers' perceptions of nutrient loss vulnerability impact their farm management behavior? And does this relationship increase the potential for disproportionality? So to help answer this question, we kind of created this theoretical model that helps us come up with a hypothesis. So this model is sort of a social science-based model that is partially inspired by the theory of planned behavior, which you might be familiar with, that basically says that of all the things that work towards changing someone's behavior, um, there's things like attitudes, motivations, behavior control, things like that. So in this vein, we think about different background factors for each farmer, such as demographics, personal things, demographics about their farm, how big is it, what do they grow, as well as attitudes and motivations they have towards farming in general. We think that these factors can influence the importance that a farmer places on physical vulnerability and the perception of physical vulnerability on their farmland. And if we can find that farmers are reacting to the perceived physical vulnerability on their landscape with increased conservation, that's a really positive thing in terms of mitigating disproportionality. So we're kind of looking to see here in a nutshell, do farmers that perceive more of their land to be vulnerable to these types of nutrient losses, are they responding with more conservation practices? And so we'll get into that today. And why are we looking into this? It's kind of about the effectiveness of policy. Are we seeing that under current conservation policy, are we accessing these hotspots appropriately? Are we able to target these hotspots? Are farmers equipped with the tools necessary to identify hotspots and treat them with conservation practices? This also can have a lot to do with how effective our outreach is. If we find that farmers are not tailoring their management to the landscape in terms of nutrient loss, that could be some really interesting room for growth in terms of our outreach and education. So the setting for this study is the Cincinnati watershed. I have no idea if I'm pronouncing that correctly after 3.5 years, but we'll go with Cincinnati. This is in southern Grant County, Wisconsin, and northern Joe Daviess County, Illinois. You can see on the map here, we're located really in the far southwestern corner of Wisconsin, northwestern corner of Illinois. So it'll be important to note for this survey that we are pretty squarely in the driftless area here. So we have pretty unique topography, pretty high slopes in this area, especially when compared to most of the Midwest. This watershed is very heavily agricultural, a lot of corn, soy, alfalfa, and pasture. Year to year, we're seeing trends of increased corn and decreased pasture, which I think is not unique to this watershed. We don't have a lot of great estimates on the animals in the watershed, but we think there's approximately 7,000, and these are mostly beef and dairy operations. And this is a Huck 12 that's been targeted by both the United States EPA and the Wisconsin DNR for improvement. It has some pretty major fishery potential, but we're currently not reaching that due to many of the reaches in this watershed being impaired for phosphorus. So some quick hits on the survey rollout. This was distributed January through April of 2023. We had 4 waves of this survey: an advance letter, a survey packet, a reminder postcard, and then a second wave of the survey packet. We also had a QR code included on each of these packets in case they preferred to fill it out online instead of mailing it back. And we're fairly happy with our response rate on this. We had 53 responses, which works out to be approximately a 25% response rate, which is within the realm of what we expect for a mail survey these days. So before I get into some of my analysis, looking at my research question, I wanted to do a little bit on the demographics of who responded to our survey. So we find a really wide range of size of the operation here. Our smallest farmer who responded owns 9 acres, and our largest farmer who responded owns 1,200 acres approximately. We got a mean of about 300 acres and a median of about 200. We also find that there's a lot of renting going on in this watershed as well, and the average amount of acres that's being rented by these farmers is 450, and on average, farmers are renting out about 90 acres in this watershed. So quite a range of operation sizes here. This is also reflected in another important demographic here. We looked at what percent of the household income is coming from farming. for our respondents, and we see a pretty bimodal distribution here. So we've got a lot of farmers where maybe it's a hobby farm, but at any rate, a smaller fraction of their entire household income is coming from this farm. And on the other hand, we have also a lot of respondents where farming is the primary or sole income for the family. So again, this kind of demonstrates that the farmers in this watershed are pretty different from each other, and there's a wide range of operation sizes and complexities here. So the first important thing we wanted to measure with our survey is perceived vulnerability. This is pretty crucial to the research question. And so we gave farmers examples of what vulnerability to nutrient loss could mean. We gave them some examples like soils that are particularly erodible, pretty high slopes. We're looking at fields that might be really close to a water body, fields that might have some water table, groundwater concerns, things like that. Um, and then we asked them to sort of self-report of all the land that you manage, about what percent of it do you think is more vulnerable to nutrient losses? And you can see here, most of the farmers said less than a quarter of their land is vulnerable, and then some of the farmers said, increased amounts. For all the analysis moving forward for this work, we split this into two groups. We've got farmers who reported low vulnerability, that's 0 to 24%, and then farmers who reported higher vulnerability. So that's 25% or more of their land they consider to be vulnerable to nutrient loss. We also want to measure the farmer's conservation intent or their conservation adoption. So we had 17 conservation practices listed in this survey. These 17 practices were developed based on local priorities, talking to the local conservation district. We asked the respondents for each conservation practice to respond on this scale. So for every practice, they had to say on the scale of I'm not familiar with this practice, all the way up to currently using on this farm. These were assigned 1 to 5, and then we created the sum total of all 17 practices, and then we normalized that by the number of practices that the respondent answered. A lot of the farmers in this watershed have livestock, so we included a lot of questions about livestock practices. But of course, we're not going to penalize a farmer for not answering the livestock questions if they don't have any livestock. So that's why we did some normalization there. And this scale, it's important to note, it's not a binary, I'm using this, I'm not using this. This gets at the behavioral intent idea where we've got to scale a process of decision making that we're representing with this score. So yeah, this is our conservation score, which I'll be referring to later. We also wanted to measure how important farmers thought vulnerability was for their decision making. So we asked them for steep slopes, high soil erodibility, proximity to water bodies, shallow water tables, and high soil p-values. How important are these factors for you when you are making conservation practice adoption decisions? And they had to score them from not important to critically important. And again, these were assigned a numeric value, and then we used the sum total to create the vulnerability importance score. We actually asked this question twice. This one shown on the screen here was for the conservation practice adoption decisions. We also asked these same questions for how important are these when you're making nutrient application decisions, and that'll come back to be important later. So what analysis are we doing here? We've got information about the farmer's conservation score. We've got information about how much of their land they assess is vulnerable. And we have information about how important they view this vulnerability is. So we're going to do a regression model here. Using this theoretical model, this conceptual model at the bottom, we're going to add a couple of background factors into this model. These are presence of livestock and percentage of household income from farming. These were the two background factors that we tested that seemed to have the most impact. And we're going to ask the question with the regression model, do farmers who perceive more vulnerability have higher conservation scores? And to sum it up, the answer is yes. So this is a really great result. We found that those who perceive more than 25% of their land as being vulnerable are more likely to have a higher conservation score than those who do not perceive that much vulnerability. And you can see a quick note here is that we found that the importance of vulnerability was not a very strong predictor of the conservation score. But we do find this pretty strong relationship between how much land a farmer perceives as vulnerable and what their conservation score is. So this is a really positive and optimistic result for sure. I will also note that the presence of livestock was negatively correlated with the conservation score. So farmers who had livestock on their operation were less likely to have were likely to have a lower conservation score than those who didn't have livestock. So I talked about 17 practices, and we were just looking at the conservation score there. But I wanted to get into which of these practices specifically seem to be different between the two groups. And we found a few: grass buffers, no-till, stream bank stabilization, rotational grazing, soil testing for phosphorus, and land retirement such as CRP. So for these practices, these had a pretty strong difference between the two groups of farmers. So those who perceived more of their land to be vulnerable were using more of these things, um, or had higher intent to use these things. The rest of the practices you can see on the right, we didn't see a lot of difference between the two groups. If you'll notice, a lot of these on the right are related to livestock, and sort of our kind of hypothesis for why this might be is that a lot of these livestock practices like fencing and alternative water supplies, feedlot diversions, feedlot relocations, these are practices that require quite a bit of upfront costs. They're constructed practices that require, you know, more capital and more time to implement in a lot of cases. And so that could be some of the reason we're not seeing a lot of adoption of these across the board compared to some of the others. So that was one half of our question is, we found that yes, farmers who perceive more of the land to be vulnerable uh, have a higher conservation score. Now we want to look at nutrient application. So this is kind of a separate issue. So we asked a couple questions about this. The first question was, do you adjust fertilizer and manure application rates or timing on a field by field basis? And this is a simple yes or no question. And we found that, as you might expect, most of the farmers who responded to our survey do adjust their fertilizer and manure rate on a field by field basis. The follow-up question for this was, if you said yes to the previous question, in areas where you anticipate increased sediment or nutrient loss, do you apply less fertilizer or manure, apply more fertilizer or manure, or I don't adjust my rates based on that? And so pretty interesting result here. About the same number of farmers said they apply less or they don't adjust based on anticipated sediment or nutrient loss. But a smaller amount of our farmers did say that they actually apply more fertilizer and manure on these more vulnerable areas, which is a pretty important finding here for sure. And so in terms of the analysis of this information, we're doing a regression again. This is a binary logistic regression. It's essentially kind of a fancy regression that allows you to look at binary variables. So in this case, our binary variable is whether or not a farmer applies less nutrients on vulnerable areas or not. We're trying, again, to relate this binary variable to the perceived vulnerability grouping, the vulnerability importance score, and the same background factors we looked at before. So again, we're trying to answer, are farmers who perceive more vulnerability on their land more likely to apply less nutrients on those vulnerable areas? And to sum it up, the answer is no. So this is actually opposite of our previous regression model looking at conservation adoption. We find that the perceived physical vulnerability has little effect on whether or not a farmer is going to apply less nutrients on vulnerable lands. Conversely, from the last regression model, we find that the vulnerability importance score is really predictive of whether or not a farmer applies less nutrients on vulnerable lands. So if a farmer thinks that these factors are important, they are more likely to be applying less. However, the same is not true for perceiving more vulnerability. So I think this is a pretty critical difference between these two types of farm management decisions. The other important thing that we looked at was these two different vulnerability importance scores. We had one for conservation decisions and one for nutrient application decisions. And we see across the board that farmers report that these vulnerability factors, slope, erodibility, proximity to water bodies, shallow water tables, and high soil p-values, are more important for them when making conservation decisions than they are when making nutrient application decisions. We find that especially the slope and the soil erodibility really are what's driving that relationship. So we see a pretty big disconnect between these two ideas of conservation decisions and nutrient management decisions here. And we think, maybe one of the reasons for this could be where farmers are going to for information and for help and for resources for these two different types of decisions. So this graph on the right here shows different information sources we asked about in the survey. And we asked them, how important are these information sources to you when you're making decisions about nutrient application on your farm? And so we find this, the scale of red to green, red is not important and green is critically important. We see that far and away the two most important sources of information for farmers when making nutrient application decisions is their own previous farming history throughout the years and their fertilizer supplier, seed dealer, or co-op. And we see that comparatively, places like University Extension or local conservation districts or the NRCS, these are less important to farmers for nutrient application decisions. So this could be part of the puzzle in terms of what this disparity comes from. So to loop it all the way back around to disproportionality, we found that 15% of the farmers in our survey said that they applied more nutrients on lands they consider to be more vulnerable to nutrient loss. So this is definitely cause for a little bit of concern in terms of disproportionality, as applying more nutrients on these vulnerable lands is going to increase these fields' outsized impact on water quality. We think the obvious reason for why a farmer might apply more nutrients on those lands is to sort of get ahead of predicted yield losses from lost nutrients. However, we sort of wonder, how effective that would be. We also found a really strong connection between conservation adoption and farming more vulnerable land. But again, this did not extend to nutrient management. So this may indicate that, a lot of our issues may be due to source reduction rather than loss mitigation in terms of tailoring management to the landscape itself. So in conclusion, we have a really great finding that we find evidence that farmers who perceive more of their land as vulnerable are more likely to adopt conservation. Unfortunately, we find that the same is not true for reducing nutrient applications. We see this as a really great place for a really great potential for improvements in extension and outreach in terms of nutrient application. Connecting the importance of the specific landscape on nutrient application could be a really great place to start. I think our results point to a potential disconnect in general between conservation and nutrient management as things that are separate. When in reality, of course, nutrient management and nutrient inputs have a huge role to play in water quality and the conservation idea in general. So, of course, this work has some limitations, as I think any survey-based work does. We don't have actual measures of vulnerability for every farmer. We have all of their mailing addresses, but this is an anonymous survey, and we don't have a sense of who's farming what field in the watershed, so we can't really get a measure of how accurate their perception of vulnerability is or is not. But again, when we're talking about decision making, what we really care about is what they perceive. We also probably have response bias here in this survey. I think it's pretty clear that those who are more interested in conservation are more likely to respond to a survey about conservation. So you have to keep that in mind as well. And we also were not able to investigate other motivations that drive conservation adoption. There is a whole gamut of literature out there talking about all the different things that inform a farmer's decision making. We only focus on a few things here. I think in terms of future work, there's two major things I'd like to see someone take this work and run with is looking at other geographies. We found that farmers here are really cognizant of slope and erodibility when they're making their decisions. But is that just because this area of Wisconsin is pretty highly sloped with lots of erodible soils? Would we see similar relationships on more flatter landscapes? I'm curious about that. Another thing I'd like to see is more detailed information about nutrient management. We asked a very simplistic question. Do you apply less, more, or the same nutrients on your vulnerable areas? This really glosses over a lot of things that farmers can do to mitigate nutrient loss from their applications with in terms of timing, in terms of the method of application, in terms of the types of manure and fertilizers used. So I'd love to see um, this relationship investigated with some of this more detailed information about nutrient management for sure. So the next steps for this work is for the rest of my dissertation, I've been taking this information from the survey and I've built a SWOT plus model using the management data that we got from the survey. So a SWOT plus model is a basin-wide watershed model that we can use to look at nutrient losses and hydrology in agricultural landscapes. And the goal of this is I've been working on quantifying the disproportionality in the Cincinnati watershed. So we're looking at where are these hotspots, how bad are these hotspots, and using some different survey scenarios to some model scenarios to investigate what's driving this inequality in nutrient loss. And then really soon, I'll be taking a crack at generating different policy scenarios in the Cincinnati watershed to look at disproportionality. These policy scenarios include looking at increasing the funding for our current conservation, getting more conservation on the ground. How could that change things? I'm looking at a potential regulation future where some baseline regulations about conservation practices are put in. And I think the most important and interesting one for me is I'm going to be looking at a targeting scenario. I'm going to take the hotspots that I've generated from my model and really focus targeting conservation adoption on those and see how much improvement we can get. So I'm really excited about both I think the really important results from this survey, but also how I'm able to use this survey moving forward to connect with some watershed modeling. So yeah, with that being said, I'd like to thank everyone for attending. It was great to be here and I'm definitely ready for some questions.
All right. Thank you, Andrew. I'll help with these logistical slides and then we'll get to
Yeah.
these questions. So first, if you watch this webinar live and are wanting to earn a CCA CEU, please email Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. All right, next slide. If you watch this webinar and are willing to fill out a voluntary demographic survey, we'd greatly appreciate that. You can go to iowalearningfarms.org/survey or scan that QR code. Only one survey response is needed for all 2025 webinars. So if you've done so for a 2025 webinar, thank you so very much. And if not, and you're willing to, that would be great. Next slide should be a plug for what's coming up next week. We have Derek Franklin. Derek is going to talk to us about more than a practice, sense of place and stewardship among prairie strip adopters. Okay, so please tune in next week and then plug the next slide, which would be that if you watch this if this webinar is archived. So if you know somebody that might like it, uh, available many different locations. And if you've missed one, please go on and you should be able to describe it. Okay, we've gotten quite a few questions and we're going to start with one. Can you break down the number of, or break down mailed versus online responses to your survey?
Yeah, that's a great question. I don't have that information right in front of me, but I seem to remember of the 53 usable responses that we received, I think only 10 and 12 were made use of with the online
Okay.
option. The
Okay.
remainder of those were mailed back to us with the Postal Service. So,
Yeah. And
yeah.
somebody asked whether you'd looked at this analysis only using those farms, say above 100 acres or more, or farms that get more than 50% of their income for farming, and whether you think there are similar results.
Yeah, so let me go back to
Okay.
that distribution. Um, yeah, I think this one. So yeah, I think that's a really good point. And we considered that. I think a lot of these really small farms that are maybe not the full-time income, I think those sorts of folks have a lot of different priorities in terms of how much time they're willing to spend on thinking deeply about conservation, about all the different decisions that come with managing a farm while also having a job somewhere else. And so we did think about separating and doing the analysis just on the larger full-time farms, but we also found that if we're really interested in potential for hotspots and for really small amount of areas to be contributing a lot of the nutrient loading, we thought it was a mistake to discount these smaller farmers who are managing smaller landscapes. I do think that if you did that and split this data up, I think you'd get some really interesting results. But I think in terms of what our goals are with this study, we wanted to make sure that we included even the smallest farmers. I hope that makes sense.
Yeah. All right. There are a few questions about kind of the vulnerability locations and the way, if I understood it correctly, you just have the mailing address of the farmer, but not the physical location of the farm or farms they might be reporting on. So, you don't have a way to explicitly, cross-reference whether that respondent would have vulnerable land based on how, we might classify that.
Yeah, and so we definitely view that as sort of the major limitation of this
Mhm.
work. And it just without detailed information from someone on the ground who's willing to share with us exactly which fields they manage, that's a really hard question to get at. Um, and so I think what we sort of were thinking about that is that, farmers are not making decisions for conservation based on the true vulnerability, however you'd want to come up with that measure. They are making it based on what they perceive. And so we felt that that was adequate for this. I think there's a whole nother group of papers and literature out there about how accurate farmers' perceptions of things like nutrient loss are. And so I've read a few of those papers, but I think little bit of a separate issue, but I definitely think, we've been thinking about that. We've been considering it for sure. I would love to have that information because I think that would be a really cool piece to add on to this. But given privacy and data concerns, it was difficult for us to get that information.
Okay. Um, there's kind of a couple related here, but um, go here. What do you what do you think the barriers are for society or public policy to address those lands that might be regularly contributing disproportionately to nutrient loading to surface water bodies and how we might work with those landowners?
Yeah, I think to me, one of the biggest barriers is just how conservation money and conservation, time and energy is allocated. A lot of our classic, equip, things like that, these are, with some exceptions, usually it's sort of a first come, first serve type of activity where farmers volunteer. They show up at the office and ask, I want to do this. How can you help me do it? And so when that's the case, um, if there's farmers that aren't as aware of conservation, they're not as aware of the connections between the landscape and what their management might be doing. These are farmers that to me don't seem very likely to be showing up at the NRCS office in the morning and getting some paperwork done. And so I think, you know, super long term, I think a different way of going about conservation delivery would be a great way to get at this question. I also think privacy is important too. It's great to say, we're going to target XYZ farmer who has the worst fields, and that gets into some ethical concerns, and how do you get that data? Um, so to me, that's a pretty gnarly question, and I think the question that motivates this work for sure is how do we get there? And I hope to kind of dig into more of that with the final bit of my dissertation that I'm working on, looking at different conservation delivery scenarios. But I think it's a policy question first and foremost. I think, the way we've set up conservation delivery in this country is not really congruent with the idea of targeting.
Yeah.
So
Okay. Um, so this individual says livestock facilities are often more regulated, and perhaps it creates a situation where following the law feels like conservation. How do we work with and help livestock farms take the next step? Any insights from your survey or perspective?
Yeah, I think the first important thing to note here is that I don't know if you've noticed in terms of acres owned, at least for me coming from Iowa, there's a lot of farmers here with pretty small amounts of land. And when we looked at the livestock numbers that the farmers reported, most of these beef, it's primarily beef, there's some dairy. Most of these beef operations are pretty small amounts of head of cattle. I mean, these farmers have 10, 20, 50, 100. Some of the dairy operations were bigger, 500, 600 cows, but so I think there was zero regulated CAFOs in this study. There's none of them that reached that threshold for the state of Wisconsin to be a CAFO. But I do think that's an interesting point. I think that a lot of these smaller operations, they're not regulated in that way. But I also think, the larger CAFOs are regulated in that way for a reason. And so I think that's a question I haven't spent a lot of time with. So thank you for that. But yeah, I think to me the biggest bridge to cross there, at least in this watershed, is less to do with the feedlots themselves, although that's important. I think a lot of the main issues in this watershed for phosphorus loss are due to cattle access to streams. I think the conservation district down there is really, really pushing, you know, uh, livestock fencing along the stream banks. And that's a really big issue they face out there. And I think that's a different issue than large CAFOs that have, effluent permits and things like that. So definitely a different focus for these types of animal operations for sure. And they're
Uh,
mostly pastured out here. There's not a lot of really true confinement going on.
okay. Okay. So that kind of relates um, a little bit to this, thinking about that the manure sources, but would the farmers in the survey have considered manure as part of their nutrient application in the questions you ask? And if so, might they be applying more manure on poorer or more problem acres and therefore more nutrients on vulnerable land?
Yes, we think that's exactly what's
Okay.
happening here.
Okay.
Most of these farmers have livestock. Most of these farmers have pasture land. And you know they have to put that manure somewhere. And I think exactly what you said is probably the reason. We found about 15% of the farmers are doing this. This behavior of applying more fertilizer on vulnerable areas. We can't say for sure whether they think in their head, this is a more vulnerable area, I'm going to apply more. Or if it's just, I'm applying more on certain fields, they happen to be more vulnerable.
Yeah.
You can't really get at that with the way we've asked our questions. Uh, but I think that's exactly the reason for what we've seen here, for sure. I think
Good
that speaks to the broader point of like manure management and nutrient management is really part of the agronomics side of the operation. Getting that to be more a part of the conservation side of the operation, I think is the ultimate
Okay.
goal for outreach. So
Uh, all right, Andrew, it's like you must have been reading the same or question I have because
okay.
somebody noted in here they found the same in Nebraska that
Okay.
producers viewed nutrient decisions as agronomic decisions, which are different than conservation decisions in their
Yeah.
mind, and do think that that's really important that we start thinking about that as a whole system and that the nutrient aspects are part of conservation as well. Certainly something we're trying to talk about a lot here also. Um, that one's more, sorry. Um, yeah, somebody just commented exactly the same that you just talked about. Um, sorry, I'm just trying to get through. Sorry, I think we've gotten that. I think we've addressed most of these questions here. The one person was, saying where they were talking about if you split out by the higher producers or the larger producers, if those results still stick, kind of some of your overall findings still stick if we're just looking at uh, some of those larger farmers. I guess one maybe last one here, Andrew, is um, kind of how And this is you talked about your SWOT plus modeling, which like, okay, we're going to get you back on when you have those results. So, like, okay, just say yes to us doing that, to
Uh-huh.
Elena contacting you. But maybe kind of what are you uh how are you going to I guess assess vulnerability as you think about doing some of that modeling?
Yeah, so it's a great question. It's what I'm doing right now, so it's fresh in my mind. So, um, in our model, for every farm field, we have access to the slope of the field, the soil type of the field, how close it is to the stream, if it's in the floodplain or not. So we can use all of these sort of GIS tools to determine if we think a field is vulnerable. And we've decided on some metrics where a soil p-value of greater than this, we're going to call that vulnerable. If it's got a slope greater than this, we're going to call that vulnerable. These are fairly arbitrary, but it's the best we can do with the GIS data. So I'm pretty excited for the model because we can really input the exact management that farmers told us they were doing in the survey into our model, and um, we're already getting some pretty cool results. So I think, taking this work and expanding it to do some watershed science is a pretty key component of my dissertation, and I'm definitely excited to see the synergy when I'm finished with it. So
All right. With that, I think that we've gotten through most of the questions one way or another, but thank you so much for all of the great questions. I think that this highlights the importance of this work and interest of this work, and we got another social science coming up next week, which I think is great. Um, I always find that, well, I find almost every one of these webinars fascinating, but especially these as we start to think about farmer decision making and relate that to our own experiences of interacting with farmers. So thank you again, Andrew. If you need a CCA CEU, please email Elena Whitaker, ALENAW at iastate.edu. Please email Elena by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. And then I would encourage you all to tune in next week to Derek Franklin that's going to talk about prairie strips. Um, with that, I thank you all for attending today, and thank you, Andrew, for your presentation. I'll give you the floor for any last comments.
yeah, just to say thanks so much for everyone for listening. Thanks for the amazing questions, and please reach out. My email's right here, adhillman@wisc.edu if you'd like to talk more. This QR code, if I've done it right, should link you to my LinkedIn.
Okay.
So please do that if you'd like as well. But yeah, great to be here, and awesome to come full circle and come back to the Iowa Learning Farms group. It's a great program and a great team. So thanks so much.
All right.